What's up, Dev? Long time no see. I hope you're doing well, and today we're going to talk about how to communicate with databases, specifically those that use SQL. I hope you're ready because we're about to start. Alright, let's talk a little bit about how our databases fit into the picture. Imagine we have a website, for example, Facebook. When you create a new account, your credentials, such as login and password, have to be stored somewhere, and that somewhere is most likely a database. Essentially, database is a storage for your data. It can hold usernames, addresses, ages, or maybe even product information you see on your e-commerce sites. All of this is stored in a database and dynamically loaded onto the page when a user requests it. And to interact with some databases, you need to use a specific language named SQL or structured query language. So this is a language that is used to manipulate data in relational databases. With SQL, you can create new records, update them, delete them, or just simply retrieve the data. So much fun, huh? Also want to let you know that not all databases use SQL. Some of them take a different approach, and we're going to review it next. So SQL versus NoSQL. You can use SQL only with relational databases. What does it mean? These databases use tables that store data in rows and columns, and we might have multiple tables that can be related to each other based on certain columns. Let's just think about example. We have a table named employee. Might look like this. Employee and table named department. We have employee ID, name, and department ID. And our department table has department ID and department name. So in our case, the employee table has a relationship with the department table based on, attention, department ID. In the employee table, the department ID column is called a foreign key. And in the department table, this column, department ID, is a primary key. So for example, in the employee table, we see that Anna has department ID 3. If we look up in the department table, we can see that department 3 corresponds to sales. So in NoSQL databases, we have a completely different mechanism. Most of the time, data is stored in the collections, such as employees collection, which contains multiple records with all their data. Let's look at the example. User collection. User ID, name, and email. So you see these objects inside of parentheses and inside of square brackets. So every element inside these curly braces is a separate record. You can think about it, right? So when you're choosing a database, you should always pick the one that best fits your needs. Most of the time, it depends on the project. Sometimes NoSQL is the right choice, and other times SQL is the way to go. It all comes down to how your data is structured and how you plan to use it. Examples of SQL databases: MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. And examples for NoSQL databases: MongoDB, CosmosDB, and Cassandra. We know enough about SQL databases, and now finally it's time to go a little bit deeper into SQL. So our query language has 5 sublanguages, each containing commands or queries that perform related activities. So here's the list. We have a data definition language, data manipulation, transaction control language, data control, and data query language. So let's review each of them. First one is data definition language, or DDL. This sublanguage contains commands related to creating or maybe defining the structure of a database. This includes creating tables and defining, obviously, their fields. For example, create table, alter table, drop table. So remember, everything related to a table, so data definition, is all go to DDL. All right, next one is data manipulation language, or DML. Obviously, this lets us manipulate the data inside tables, including inserting, updating, or deleting records. Example, insert, update, and obviously delete commands. So next language is DCL, or data control language. These commands are responsible for allowing or restricting access to databases and tables. You can grant or revoke permission for certain users. So think about admins that can get all necessary permission, or some users that will just have like a certain access, right? So our commands are grant and revoke as an example. So next one is a data query language, or DQL. Includes commands that retrieve data from tables. You probably saw already select something from table. This is data query language, DQL example. And the last sublanguage is transaction control language, or TCL. This one can be a little bit more tricky to wrap your hand around, but it lets us treat a set of commands as a single unit of work. You can use commit, rollback, or begin a transaction. So I think it's easier to understand that if you think about a bank transfer. So you either transfer the money successfully or your transfer will fail. So similarly, if you have multiple commands that wrapped in a transaction and one fail, the entire transaction fails. So this is all about transaction control that helps you to treat your commands, SQL commands, right, as a single unit. So commit, rollback, and save point are very common commands from this TCL. All right, now let's review common commands that SQL provides for us. So let's start with create database. Create database, my database. After we create our database, we can create a new table inside of this database. So let's try to do this one. Create table, users, user ID, integer primary key, name varchar 50, email varchar 100, and age int. So quickly talking about these new words int, varchar, and primary key, right? So int and varchar just simply means a data type, right? For example, it can be text, it can be number, date, etc., etc. Yes, so when you define a new table, remember DDL, definition language, you have to make sure you also create your fields, so columns, with data types, right? For example, for age, it makes more sense to have a number, and for username, it's a varchar, right? Character variable, pretty much. Okay, so let's move to the next command, inserting a new record. So after we created our database, we can insert a new data in it. So the command will be this one, insert into table name, and we can specify what table columns we want to insert the data to. In our case, we want to insert it to user ID, name, email, and age. And now we have to specify values. Values 1, let's call it Anna at example.com, and age will be 25. So we have one record in our database, and to retrieve the data from the table, we can get all users or specific users, right? So let's just retrieve all users. Select this asterisk means everything. So all columns, in our case, will be user ID, name, email, age. If you want to just retrieve a few columns, that will look like select name, comma, email from users. Remember, users is our table name. Where clause, age, it's a column name, right? More than 20. What does it mean? We get users that has age more than 20. So for example, if we want to update data, right? For example, we want to change a new, email for Anna. So we're going to say update users, set email, for example, Anna new at example.com, where user ID is 1 equals 1, right? So for example, if we just set, if without where, it's not going to work properly. Pretty much we're going to set emails for everyone, anna.net@example.com. We don't really want to do that. So where clause really helps us a lot. The same thing for deleting. If we want to get rid of the record from our table, we can just say delete from users where user ID is equal 1. Again, if you forget where clause, you're done. You're cooked. your records are done. Okay? So where clause helps us to filter data based on a certain criteria, right? So in our case, it's like columns, right? And since we start talking about where clause, I would like to mention a few more constraints and clauses in SQL. So there are different types of constraints, some of which we can use when creating a table. For example, not null, unique, primary key, and foreign key. You're already familiar with those. So not null obviously ensures that a column cannot have a null value. Unique obviously ensures the records in the table are unique and do not repeat. For example, it's a bad idea to put name column as unique, because imagine you have one Anna, but you're not allowed to have another Anna. So this is also needs to be considered. So another important concept is clauses that help you to filter and organize data. Some of this includes where, order by, group by, and distinct, and others. So many of these clauses are used in select statement to filter, sort, right, order by, or group your data, which is extremely helpful when working with a large data set. So you can definitely check out more of these clauses. That's pretty entertaining. And the last thing I want to mention is SQL flavor. So as you already know, there are many database services, MySQL and others, made by different companies. And depending on the company that created the database, right, they may have slightly different SQL syntax. The differences are usually not huge, but MySQL and Microsoft SQL Server, for example, might have variations in their syntax. So it's always a good idea to check the documentation, and most queries are similar across the platforms. But if you're using something specific, the syntax might differ. So being aware of these differences can save you time and prevent errors, obviously. So I hope this was very helpful for you guys, and you'll continue to come and stop by, and we can explore more of the programming world together. Don't forget to like and subscribe to my channel, and happy coding!